Alright, so last week we talked about ionic bonding and how ionic bonds or ionic compounds are formed from the transfer of electrons from one atom to another. This week we are talking about covalent bonding, and we discussed some of this yesterday. We're just going to review over everything so we can practice Lewis Dot structures. So remember, covalent bonding is the sharing of electrons. So neither atom or neither element has full ownership over electrons that are bonding together. So that means that these two electrons represented right here are not owned by either fluorine atom, but instead they are sharing. So these two valence electrons are going to kind of bounce back and forth equally around these fluorine atoms. Right? Remember, all covalent bonding occurs between two nonmetals, and what we use to represent these are our Lewis dot structures. Remember, these Lewis dot structures show you how these molecules of covalent compounds are organized and how each of their valence electrons are organized and shared among each compound itself. Remember, when we're talking about covalent bonding, we look at our diatomic molecules, and diatomic molecules just means in nature or when they're by themselves, they appear in pairs. So hydrogen, when it is by itself or in its pure form, it's always pairing with itself. So this is showing that hydrogen pairs with itself. Same thing here, nitrogen's pairing with itself. Oxygen is diatomic, fluorine, chlorine, bromine, and iodine. So all of these are diatomic and can bond with themselves. So as I've already shown you here, fluorine has 7 valence electrons. So that means that the fluorine atoms are going to create one single bond between them, and that way each of them have a total of 8. Right? So let's go ahead and dive into our Lewis structures. I gave you steps yesterday in your notes that you can look back to. But basically, you will be given a problem or a molecule that you are going to draw the Lewis dot structure for today. So yesterday in your notes, we looked at CH3Cl as your example. So step 1, we are going to draw our central atom. And usually, if carbon is present, carbon will always be your central atom. Okay, so we do have a carbon present here, so we're going to make this the center of our structure. Next, we are going to draw the peripheral atoms around our central atom. So these are our peripheral atoms. We have 3 hydrogens we need to place. So 1, 2, and 3. And then our chlorine, which we're going to place right here. All of our peripheral atoms are going to want to be as far apart as possible, and it's because of their overall shape or Vesper properties, which we're going to talk about more on Wednesday. So I always draw them as far apart as possible around the central atom. All right, our third step is we are going to add up all valence electrons. So what we do when we add up all of our valence electrons is we are showing how many valence electrons we are going to place around all of our atoms and how many should be present in our Lewis dot structure. So first off, we know carbon has 4 valence electrons. We know hydrogen has 1, and we have 3 atoms, so we have to multiply it by 3. And then lastly, we have chlorine, which has a total of 7 valence electrons. So 7 plus 3 is 10, plus 4 is 14 electrons that we are placing. Alright, so next we are going to bond or place electrons between our central and peripheral atoms. Okay, so that means we are going to put 2 electrons here, 2 electrons here, 2 electrons here, and 2 electrons here. remember that the dots, or two dots, two electrons, also can be represented by a line. So this also can be written like this. So I still have 2, 4, 6, 8, 2, 4, 6, 8. So I have a total of 8 placed, and I need 14. So that means there's 6 more that needs to be placed. All right, hydrogen only makes one bond because of the honk rule. Right? Remember the honk rule. Hydrogen always forms one bond. Oxygen has 2 bonds. Nitrogen has 3, and carbon has 4, and that's based off of how many valence electrons they have. So carbon is going to have the total of 4, which we have, and hydrogen only has 1. So because of this rule, that means all 6 electrons that still need to be placed are going to be put around my chlorine atom. Okay. So lastly, we check to make sure we placed all 14 and that our atoms have 8 valence electrons with the exception of hydrogen. So I see carbon has 2, 4, 6, 8, and chlorine has 2, 4, 6, 8. So everything is good, and that's how I know that my dot structure is correct. Alright, with that in mind, we have some structures that are not as clean when we are drawing them. It's not as easy based off of the total electrons we're given. And usually when they're not forming single bonds and they're forming double and triple bonds, that's when we run into issues. So if we were looking at, let's say, carbon and oxygen combined, we would put carbon as our central atom and oxygen as our peripheral. So then we add up our valence electrons. So I know carbon has 4 and oxygen has a total of 6 valence electrons. That means I'm placing 10 electrons. Right? So what I do is first I bond, or I put my electrons between my central and peripheral atoms. And then I go ahead and place my other 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So what I notice is that carbon has a total of 8 valence electrons, but oxygen only has 4. So that means I need 4 more electrons to pair with my oxygen. So what I do is I take these pairs of electrons, or lone pairs of electrons on my carbon, and I move them to the center between carbon and oxygen to create more bonds. So now I have total of 6 electrons being paired between my oxygen and carbon. So what this represents, my 6 electrons represents a triple bond. And so this would be my Lewis dot structure for carbon monoxide. Okay? And then lastly, yesterday we talked about ions. Remember ions, we are adding and subtracting electrons. So we have an ion oxygen 2 negative, which means we are adding 2 electrons. And then we had magnesium 2 plus, which means we are losing electrons. Okay? And looking at the dot structure of oxygen, I know that if I'm adding 2 electrons to its already 6 valence electrons, I would have a total of 8. And when I'm drawing an ion Lewis dot structure, I put it in brackets and show how many electrons I've added or subtracted. That being said, if we look at your polyatomic ions on the back of your periodic table, you can see sulfate is SO4 negative 2. And what this shows me is that I'm going to add 2 electrons to the total amount of electrons for sulfate. So first I'm going to place my central atom, and if carbon's not present, it's usually the one by itself or the one in the beginning. So sulfur, and then 4 oxygens around it. So 1, 2, 3, 4. So I've placed all my atoms. Now I'm going to add up the valence electron. So I know sulfur has a total of 6 electrons. And oxygen has a total of 6 electrons. What I notice here is that negative 2 means I'm really adding 2, so I would add that 2 next to my sulfur and oxygen electrons. So 4 times 6 is 24, plus 6 is 30, and then an additional 2 is 32 electrons that I'm placing. Okay? So with that in mind, I'm going to go ahead and connect, or put my electrons, connecting my central and peripheral atoms. So 2, 4, 6, 8. So now I have a total of 24 that still need to be placed in my Lewis dot structure. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now I check to see if I have my 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I've met this requirement here, and now I have to see if all of them have 8. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everybody has 8, so that means I'm done. I will put my ion in brackets because I had to add 2 electrons, and so that shows me that if I didn't add these 2 electrons, I would have had to bond somewhere, and it would have caused some issues, whether you're double bonding here and creating too many electrons for sulfur, or whether you had to move an electron around with oxygen and have your oxygens pairing and then with sulfur. It would get very confusing. So that's why when we are drawing Lewis dot structures with ions, it's showing you that we're adding 2 electrons to make all of our elements within that atom stable. So hopefully this review helped you guys a little bit. Go ahead and complete your Lewis dot structure practice from the sub. First you're going to complete parts A and B of your unit sheet, and then you're going to look at the handout given to you.